Okay, so welcome everybody to our PRISM virtual seminar for this fall. So we're really excited today to have Professor Frauke Kreuter joining us. So Professor Kreuter is a director of the Joint Program in Survey Methodology at the University of Maryland and a professor of statistics and data science at the Ludwig-Maximilians-University of Munich. She's an elected fellow of the American Statistical Association and the 2020 recipient of the Warren Metofsky Innovators Award of the American Association for Public Opinion Research. Dr. Kreuter is also the founder of the International Program for Survey and Data Science, the co-founder of the Coleridge Initiative, and the co-founder of a podcast called Dig Deep. So with that, I'll turn it over to Professor Kreuter, and we're really excited to hear your talk today.
Thank you very much for having me. This would only be better if you actually had me in person, which hopefully we can do at some point. I'm in my normal life, or in our normal life, still a lot at the University of Maryland, despite the German affiliation. So hopefully next year there will be an opportunity to visit. So if what I will be throwing at you will be a lot of data and a lot of research topics. So if any of that strikes a chord and you feel like there's room for follow-up, don't hesitate to reach out. There's way more work than I or my team can handle. And so in particular, the students that I saw introducing themselves on the chat, if this is of interest, we always are interested in having people working with us. All right, so the topic I brought with me, and I hope this is of interest, is a little bit of an overview of what I call digital trace data, the different modes they appear in, how those data are collected, some applications, and a little bit about errors, since some of you know the field of survey methodologists is all about sort of looking at error sources in data. But I do think that as a sociologist or as a methodologist of any type, it's good to be aware of that, because you might end up using those data, or you might end up citing studies that use these data, and I think we all need to sort of get a feel for them collectively. I structured my talk in 3 buckets of unequal length, but I will try to pause after each. And if you have questions, feel free to ask them then, or we'll do that afterwards in the discussion. So both works for me. I've given now plenty of Zoom talks, so I will not be flustered if you interrupt. And if you post it in the chat, I might not see it accidentally. So apologize for that ahead of time. So the 3 buckets I want to talk about is the first theme I want to talk about are sort of what happens right now in data production, a couple of challenges that maybe not everyone here is aware of, a couple of new opportunities and excitements about new measurement. That's sort of the blue one. And then I do want to take sort of the methodology perspective and talk about the fit of these data to research questions, and give you a case study that showcases a couple of these different data sources and how they can be used, and what kind of research questions we try to answer with them. And then the third element is a couple of things to think about, and maybe research for the more qualitative ones to dig into, because these data come with new challenges that many of the statisticians haven't tackled yet, and algorithmic fairness and things of that nature are part of it. So let's jump in with the challenges in data production. Frequently I visit the Pew Research website when I'm having a bad day and feel like I need more input to have an even worse day. Because what you see here on the left is sort of the decline in response rates in telephone surveys, in this case, over the last decade or two. And I mean, the graph could be drawn differently, and it wouldn't be look like such a steep decline. But even if you just look at the fact that in 2018, only 6% of the people they tried to reach participated, that makes one pause, in particular in times like right now, where we all look at opinion polls in the election context and think they are meaningful, and I still believe they are, but it does raise questions. We have seen a bit of an uptick in response rates when COVID started and all the surveys that tried to sort of measure COVID-related things started, but that has quickly vanished. You know, I thought I could make a new story about response rate, but no, it's still a downward trend. And so as a result of this trend, there have been a few years ago now, a couple of initiatives started to look into alternative data sources. And this report that you see on the right is the first volume of a two-part series from the National Academy of Science. It's freely downloadable on the National Academy's website on sort of federal statistics, multiple data sources, and privacy protection. And the idea being sort of to develop or look into alternative ways that the federal statistical system, but largely data on humans, I would say. And for that to be very relevant to social scientists, could gather data and analyze them and have a different system that doesn't rely as much on surveys, let's put it this way. The biggest piece in that, or the biggest learning in that panel, I was part of the panel, and I think the whole panel started out thinking, oh, now we're all using Twitter and the company data and what have you, but it became clear pretty quickly that the biggest focus going forward is probably the access of administrative data. And since then, a lot has happened. There's a new legislation out that allows access to these data. There's this pamphlet just came out, a little book just came out from the Data Foundation on modernizing the US data infrastructure. There is a lot happening in that space with agencies of all sorts now being mandated to make their data accessible for researchers and finding a way to do that. And so we will see new federal data enclaves pop up and being developed where that is possible. What I mean with administrative data, for those of you who are not familiar with that term, and if you happen to speak German, then you can like dive into this. Too small of a print, probably, at least if you look at this on a laptop. But it is just a typical form, you know, for administrative data. In this case, it's the Social Security notification when an employer hires an employee in Germany and they fill out, you know, stuff about them, address, and a little bit of social demographics. And then most importantly, their start date of a job and what they earn, right? Which creates pretty good earnings record, way better than any survey would. And increasingly, these administrative data are available in digital form, not just in the US, but across the world. And what's pretty exciting is that not just these, but data from all kinds of administrative processes are increasingly available in digital form. So again, another example from Germany, we had still, you know, the German Democratic Republic Times, you know, there was a big sort of complaint system that they had to town officials and what have you, and they kept everything. I mean, think Stasi and all the libraries of documents they had, right? And all of that is digitalized, or many of that is digitized right now, including letters written to the city officials and complaints. And you know, as you digitize that and then have automated text recognition and be able to automate this automatically, there's a treasure trove of data now available for sociologists, if that's the kind of thing you do. One of the problems with these administrative records is that they often have more of a data protection statute than survey data have, right? I mean, we go through IRB, we have a consent form, and then once the folks participate, we're usually in the clear. That's not the case when you analyze wage records, say, or other Title 13 directed records. And that was one of the reasons why we founded this Coleridge initiative that Rafi mentioned earlier, to create a secure environment inside the Amazon cloud, but it could be a different cloud provider, doesn't matter. One that is what's called FedRAMP secure. So there's a federal security protocol to create boxes within AWS so that you can analyze confidential microdata. What's been interesting, in case you want to do something like that, the way to unlock the data from the cities or state level agencies is to work with them on problems that interest them, right? Because then there's like, okay, let's have researchers and the students and the government employee meet, learn how to use the tools and the data and solve some problems. And with that, we have engaged, this is already outdated again, lots of agencies, 50 plus at this point, from all levels, that provided data. And the interesting thing, and I will come back to that in a moment, is once they get connected from the various agencies, and you see a good representation of New York based ones on these logos here as well. So why is this all exciting? I mean, there has been a lot written on sort of digital traces, and different definitions are out there. I like the first one you see here, that basically there's a string of activities that we do, and increasingly they leave a trace. And whether this is my interaction with a government agency, or my interaction with Google search, or actually the conversation we have right now, right? It is recorded. So someone can analyze that afterwards, and then analyze, maybe have a totally different research question on, the lighting of a speaker and the hand movement and how that affects attendance or attention, or later on when we have a discussion, do we interrupt each other? Is there a difference between males and females on how they communicate? I fully expect communication researchers to take advantage of all these Zoom recordings that are out there after the end of this year, right? Because we produce these digital traces. Now, one thing though to keep in mind, if you look at the right here on that page, is that what we used to do in the past is we designed data, right? We had a clear plan, a research question, and we needed an experiment to do a hypothesis testing. And then, a lot of thinking went into having a good design for the experiment. And then once you have your data, you do the t-test and you're done, right? I mean, not quite, but then it gets a little complicated if people don't comply to the treatment and control group and all that. But by and large, it's fairly straightforward to analyze such data. Similar to surveys, right? There can be years of questionnaire development. I mean, I don't know if you guys hung out in census or talked to census folks, but, they, not kidding, need a year to develop a good measure for race and ethnicity, or a good measure for, how to ask the gender question, right? There's so much thinking and so much pre-testing going on to create that measure. But then once it's there, that's what we take as the right measurement, right? So all the work happens prior in the design stage. With these digital trace data, they arise organically, right? I mean, almost should move the button to the other end, right? Because all the work to create measures happens after the fact, right? I mean, I have these administrative data, I have data from social media that Roberto Rigamon, who threw out this chart in one of our academy's meetings, called aspirational data, because it's mostly aspirational what we put on social media. The transactional data, it's there. It was there for a different purpose. It's not yet a measurement, right? And so there's a lot of work coming our way. I mean, it seems easy in the data available and cheap, but there's a lot of work coming our way to create measurements out of these data. But before we talk about that challenge, let's look at that landscape a little bit, where we are these days with the digital trace data. I had fun sort of trying to chart this out with a colleague of mine, Florian Keusch in Mannheim, to sort of think about, both individual behavior and social interactions, and where the different activities are on a digital analog scale these days, right? And I would love it if you disagree where we place these things, so it's still a draft, and under review we can change it. But, let's take driving, for example. It's, largely an individual behavior and increasingly digital. I mean, I fully expect in 5 or 10 years that to be all the way on the left, right? So stuff is moving, of course, in this chart. This is a snapshot right now. But I think it's fair to say that a lot of behaviors that we used to think of as being entirely analog have now the possibility for some digital traces, whether it's collaborative work or, even our physical activities. They have a digital trace. If I'm not wearing my smartwatch right now, but if I were to wear it, then even the movement that I'm doing right now with my arms would be recorded, and there's some digital trace of it, right? So which means if you're a social science researcher, that there is a lot you can capture with all the sensors that are already in place, or with a little bit of creativity that you can put additional sensors into place, right? And that's true for both researching individual behavior as well as social interactions. The benefits that are often associated with the fact that we have so many digital trace data is that you can now measure moment in time, you know, that you don't have to do all the, like, deal with all the recall problems that we have in surveys, that there's very little burden on the respondent. You can scale this up, you can, you know, measure this on everybody, and it's non-intrusive, right? And so with the non-intrusiveness, there's a hope that there's less measurement error. We'll come to that. I think that might be an illusion, but that's sort of the hope. The caveat for many data sources right now, it's still highly selective because we are not fully digitized yet, right? I mean, there's still a lot of analog behavior. And as I just mentioned, you know, not wearing my smartwatch right now. And so is not recording the movement. But there are also, of course, plenty of people that do not own devices or don't use them in the same rate. But those that do, or many of us, have one device in common, which is our smartphones. And it is amazing, you know, if you look deeper into all the digital traces that the smartphone itself can collect, right? So this is a picture of the sensors that are built in almost every smartphone that we have. They can measure proximity through Bluetooth or the near field communication sensors. They can measure location either through Wi-Fi, GPS, or the cellular network, or all three of them. That will be an even better measure. Lots of different sensors to measure physical activity: accelerometer, gyroscope, pedometer, you know, compass. All of those can be used, and then ambience, you know, things like that. So, you know, and the interesting part is it's actually not hard to activate these sensors, right? So I'll come to that case study in a moment, but if you program an app and you want to tap into these sensors, it's pretty straightforward, and getting the data off the phone is pretty straightforward. So, I mean, I can't do it personally, but, you know, talking to folks that can, it was done so fast and so cheap that it can't be very hard. That was my conclusion. So, in addition to these sensors, the phones are interesting in a different way also. You know, we hear the term metadata, or, you know, other forms of ways to describe sort of an outside view of what happens on the phone. So one thing that's also easy to capture from the phone is to see what's on the front screen of your phone, right? So that which app are you using at that very moment, right? And how long. And so what you see here on the left is 10, I think it's 10 people for each of these groups: full-time employed, part-time employed, and job seekers. And over the course of 24 hours, every app opening and closing that these people have done, and the different colors in these, so each little stripe is an app, and the length of it is sort of how long it was open, and the colors are related to a type of app that this reflects, classified by the Google Play Store, right? So, yeah.
Quick question. So how did you decide that these people were part-time? Was it a priori or a posteriori?
Yeah, so this excellent question. This came from a survey that was fielded at the same time as these data were captured. And so a combination of data sources. Yeah, so the self-reports in this case. The case study I'll come to later, we have administrative data, but that's it. These data here came from Ipsos. That's a data collection company worldwide, but also present in the US. And they had a panel. You see the date here, 2014 to like throughout 2014, basically, where people signed up and against pay, you know, said, okay, sure, you can monitor what I'm doing on my phone. Not reading what I write in a text message, but whether, you know, I have such app open or not, right? And so anyway, we got access to these data for about 1,500 people over the course of a year. And I had a big data hackathon challenge with some students, and one team came up with an interesting idea to just look at what kind of apps are these different types of people, these 3 different groups using, and classified emails and entertainment apps, right? And the email app use over the course of the day, that made a lot of sense. The entertainment app was a little shocking to me as an employer of folks, that during the day there's still almost as much entertainment app usage among the full-time employed as there is among the part-time employed, and a little diversion from the job seekers. Now, this is the roughest analysis. This is just to motivate. What this chart helped me do was actually to convince the German labor market agency to do such study for real, and that's the case study I'm going to show you in a moment, right? But just a teaser up front. So Mark's question is the perfect segue to what I want to talk next, right? So this is, but wanted to get you excited about the new data sources and the potential for measurement. But to do this right, it can be hard, and it can only work if you can fit it to a research question, right? In order to know, does it matter whether I'm missing people, in order to know how to construct these measurements. And as we will see in a moment, most of the time, these digital traces are way too poor in terms of information they have, and you need some additional information. So in this case that you just saw, well, the app usage by itself doesn't tell me yet, is this a full-time or part-time or, a job seeker? I need, some other way of labeling the data, some training data, some outside source, to enrich it. They are usually, they're rich in cases, narrow in features at the beginning, or when you create them, it's all of one type. And social scientists, we're often interested in more complex behavior than just the next click that you would do, right? So at this point, I always like to quote my friend Roger Peng from Johns Hopkins University, who said about data analysis that this is a product, or to think of data analysis as a product to be designed. And I would argue that we should have that same attitude towards data collection, right? It's really we're not just collecting them. We're making so many design choices on what to capture, what not to capture, how to take it, and what to do with it afterwards. And that can only work well if we have the end result in mind. And as much as we all love the open science and the reuse of data and what have you, if it's not collected or measured or the feature created for a certain purpose, it may or may not fit the next thing that you would be wanting to do, right? And so the biggest objection I often face when I talk about this is that people say, it's like, well, but these digital trace data, there's like no sampling probability attached to them. We have troubles making inference, what's this all about? And we should just stay away from it, right? And I think, we think about our research questions. It does help to think about what is it that we're really doing. And I would fully agree, and that's why the Census Bureau and the Federal Statistics Agency basically threw this out, and said, well, we're working with administrative data, but not with the other digital trace data, because their main area of work is descriptive statistics, right? They want to get point estimates for the entire population, and that's just almost impossible with these kind of data. There's no inference basis, and to do this right, the description and the statistic, you need to know the selection probability, and you need to have a positive selection probability for everybody. But I would argue that's only the case for that kind of task, right? The descriptive statistic. We probably can get away without knowing the selection probability in the causation and prediction part. I mean, we still want everybody to have a positive selection probability. We don't have sets of the population not even be in there. Or if then we would want to know about it and say our inference doesn't hold for these guys. But the knowing the selection probability is, I would argue, much less important. And so in the field that most of us social scientists operate, we're not dealing with the statistical agencies. I think there's a lot we can do with the data. Granted that we combine them. So why am I saying this? And let me use this visualization to make that argument. So what you see on the left here is a picture of Vincent van Gogh of the street of Paris, right? Nice little terrace, some tables there and what have you. That's the reality, right? That's what we're trying to get at. With these digital trace data or big data sources, however you want to call them, all we get is a blurry picture, right? We have lots of data thrown at us from everybody, but it's not a good measurement. You know, it's largely data noise, if you will. We are used to something else. We are used to precise measurements that we designed earlier, but we have, you know, a selected snippet of the population, and, you know, usually actually better done, stratified by something we know. And, you know, maybe I should update this picture and have some little bubbles at various places, but you get the idea. And so I think an interesting challenge, looking at Jennifer here, you know, as the statistician to tackle those, is how do we combine them so that we can, from the designed surveys or whatever the data collection might be with the precise measure, add on or combine that with the digital trace data to model out the rest and get a better picture, right? And I do think that there's a lot of room still for us methodologists and a statistician to tackle that piece. Now, let me give you, as promised, this example from the IRB smart studies to sort of move away from the abstract part. But before I do that, any questions or comments to what I just said?
If I'm going to push back on the causal inference part at some point, do you want me to do that now or later?
Now that you unmuted yourself, why don't you do it now and give people a break?
So I'm like super excited about this and super scared all at the same time, right? And I know that you're like one of the most thoughtful people in this area. And so you're not, at every step of the way, you're understanding the limitations, right? And trying to solve them. So I guess I would push back on the causal piece, like the not worry about selection, because I feel like, at least the way I teach causal inference, the way I think about causal inference, I don't just want to know that there's, you know, a treatment effect for that population. I want to know who that population is, because particularly in social science, we don't think like there's a treatment effect that holds for everyone, right? But it's very context specific. It's very, right? So I think, so, I mean, the devil's in the detail here, right? But not knowing who we're talking about, I feel like can be really problematic. And also, I mean, this is nitpicky, but more and more in causal inference, we want to know more specifics about treatment effect heterogeneity and what are moderators, whatever, and that feels harder in this.
Yeah, so thanks for allowing me to clarify that, Jennifer. When I meant the selection probability, I really meant sort of being able to quantify the probability with which someone was selected. Like, let's say you have a household of 4 and knowing that, you know, this is 1/4 of this household member that you represent. So really from a statistician hat having on, what I meant with positive selection probability is making sure that every element of the population or every group of the population is somehow represented in our data, and ideally I know something about them. So I think you had, I mean, when you mentioned there's like
that's a harder task, yes.
Exactly. So the, you know, the reliance on probability sampling requires, right, that I know the selection probability and can quantify it. What I think we need for causal inference is that we can be sure that there is no unobserved effect heterogeneity, right? That's what we need to know. And ideally we have all the groups we're interested in our sample, and then we can have enough of them so that we can test the causal effect for each of these groups. But it doesn't necessarily mean that in order to know that I can recreate the entire population because I know the exact sampling probability. That's the part I was talking about.
Yeah, no, that's fair. That's fair.
So thanks for clarifying that. And it, you know, this is because I often talk to statisticians, and you know, they love to do complicated samples.
Yeah,
and get high gamma in it when we loosen that, you know. So.
Yeah, and it's also true that we end up with convenient samples all the time in causal inference and have no idea who we're making inferences about. So you know, that's
exactly right. I mean, this is well tested in the medical field with all the caveats of generalizability that, you know, they often overlook groups that are important in all of that, right? But it's not unheard of to make causal inference from a convenience sample.
No, it happens all the time. And the other thing I was going to ask is, are you going to talk at some point, or will you talk at some point, please, about like all the ethical or some of the ethical issues?
Yes, that is the third pillar. Yeah.
Okay,
absolutely.
great, perfect.
Yeah,
Okay.
yeah. You cannot give this talk without talking about that. So yes. Okay, so let me. Thanks for the interruption, and I truly mean that because I find these 45-minute Zoom webinars otherwise quite hard. So thanks for volunteering the discussion. So let's dive into the IRB case study. So what is IRB? That's the Institute for Employment Research, and one of my German affiliations is sort of part-time with them. And you know, it's like the Bureau of Labor Statistics or any sort of research shop that has to do with the labor market. They always worry about the effects of unemployment, in particular long-term unemployment, on sort of chances to re-enter the labor market, say, right, or other adverse effects on people. And some of you might know this study here. Is like if you studied sociology, you know may or may not have come across it. If you studied sociology in Germany, you definitely came across it. This piece by a group of Austrian social psychologists, and the Arbeitslosen von Marinetal, Paul Lazarsfeld, Maria Jahoda, and a few others. They went into a town in Austria in the 30s at the time of a massive layoff, right? So they all moved in, stayed there for several weeks, and then placed themselves and their poor graduate students probably at street corners and in people's houses. And then they measured how long does it take people to walk over a bridge? How many people gather at a street corner and talk? What's the rhythm with which people get up in the morning and go about their business? And there's a movie made out of this, and a famous line that, you know, all of a sudden it was noon, you know, and I don't know if you've ever been unemployed, but, you know, the daily structure can sort of slip away and you know, ultimately makes it hard to re-enter the labor force. And so that is an observational study, you know, n equal 1 in this town, you know, but a lot of labor market researchers, in particular coming from sociology, relied on that insight for years, for decades, you know, to have their conclusion. And with the survey methodology and the kind of questions we ask in surveys, I would say there was only partial possibility to dig deeper into that kind of thing, in part because people forget what they do. It's hard to keep track of things you do. It's, you know, filling out diaries is laborious, and reporting that you stay in bed until 11 a.m. might be socially undesirable, and all of that, right? And so what we thought, inspired by that study that I showed you earlier with the smartphone apps, was, okay, well, let's see if we can do a 2.0 version of this Marinetal study and use the smartphone sensors to monitor all of that, what folks in the 30s, these researchers monitored in the town, right? We can see with the accelerometer how much people walk around, what's the activity level. We can see how much communication with someone else they engage in on their phone, right? We can see what, you know, I mean, we can measure what types of apps they're using and things like that, right? The size of their network by reading out their address book and the like. And so we're barely having touched the data after all the cleanup, and I'll speak to that in a moment, on the substantive side. But what's pretty interesting, sort of as a sneak peek on the results, is that this loss of daily structure in the way reported back in the 30s is not something we see in these data so far. You know, our first glance is that there's, sure, if you look at the right here, a little bit of a difference in the morning. This is again the 24-hour scale that you saw earlier, from 0 to I mean, from midnight to midnight, and the day starts somewhat later for the unemployed, but then the rest of the day structure doesn't vary as much as one might assume, and the same is true for activity hours in general, at home and away from home. What's interesting though, since I created this, actually, one of my students broke this out by males and females, and it turns out this does not hold for a certain segment of males, you know, so there is a very vulnerable male population for whom the disintegration is really still very visible in the data, but that will be another talk. So anyway, to make this possible, right, a lot more data is necessary than just the smartphone app. So what we've done in order to run this study was we recruited from a long-standing panel survey where we had prior information on all these people. You know, several thousand cases that had been part of this panel, plus these data linked to the kind of administrative data that I mentioned to you earlier, the employment records that the Social Security Administration records. And this allows us to get at some of these inference problems that we mentioned before, right? I mean, for one, not everyone has a smartphone, right? And we had in the survey, in the panel study, initially asked, you know, do you own a smartphone? What type? The kind of measurements we took from the phone are only possible on Android devices. iPhones are locked too much. You cannot capture so if you have an iPhone, you can be pretty safe that apps on it will not tap into all of it. But Android devices allow that, and then, but then obviously we have a sample of the Android users, and we have non-response or non-participation error in not participating in our study, not being willing to download the app, or not allowing us to tap into the census. Now, just briefly, how big is that error? Turns out it is surprisingly small. First of all, you know, by now, actually 80%, this is a couple of years ago, so 76% of the German residents, this is now based on the probability-based survey that we have proper selection rates and can weight it up to the population, just to close the loop on that, own a smartphone. But what is interesting, what you see in the graph here over age groups, so the lowest group here, 15 to 19, the oldest 75 plus, there's quite a difference across the age groups. What was interesting to us is that overall, the Android owner population pretty much mimics the overall population. So we have a segment of iOS users, and they are different, but they're small enough so that they're different. I mean, missing them actually does not reduce the generalizability of the Android users. Windows Phone marginalized, somewhat more popular among the elderly. I can attest that my parents are avid Windows Phone users, and it's terrible, but very hard for me to help them. What was interesting in terms of participation rates or non-participation error, here's a graph just showing you the participation rates for each of these functions. So what we asked people, explain why we needed and asked them to give us access to was their network, so that we can do geo-positioning, which we used to look at the activity radius, but we also used it to field questions to them if they enter a certain area, you know, so they are in a job center for more than half an hour, presumably getting advice, and then as they left it, we would ask questions about their experience there, right? So that we pre-programmed the geofences into that app, and anyway, didn't really work. So it's a fun thing to do, but it's not worth the effort. But anyway, we needed the geoposition for the activities. We asked for interaction history. So any phone call or text message received was protocoled by us. We had access to the social network or data, meaning their address book. And what we did is we hashed the phone number so that we have a not to us readable, or anonymized ID, if you will, for every phone number they called or interacted with, but then we were able to capture the counts. Prior to hashing a contact, we pinged the first and last name against a name classifier to get sort of a sense of name origin, and a gender classifier to get a sense of whether this is a female or male, right? So noisy measures, but better than no measures about the network, right? And then we had the activity data, the pedometer, basically step count, what it boils down to, and the smartphone usage data. What was interesting for those people that participated in the study, they all said yes to all of these things. And we did some qualitative studies ahead of time, and it's like any of the apps you install, you know, people click yes, 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 yes. You know, they just, I mean, once they agree to participate, you know, there's not much differentiation. I thought no one would give us the geopositions. Others had their bets on no one will give us address book information, but that was not true. The only reason that the smartphone usage shows a little bit of a lower acceptance rate or activation function is we had to switch the screen and go somewhere else in the phone to make that happen. And so there was just more friction to do that. So in the interest of time, I'm not going to walk through these and walk straight into, is that okay to do, right? So we ask for a lot of data, you know, and I can see at least on the 4 faces that I see here easily on the screen that this is somewhat frightening, you know, to capture all this information. And it truly is. It's also very difficult to now make the data available to others, you know, who are outside the IIB and want to do these analyses. What I think is, you know, a challenge for all of us as we engage with these kind of data is that increasingly, you know, the data scientists and statisticians don't only talk about fair algorithms and have your machine learning algorithm not discriminate people, but also about fair data, and fair meaning a slightly different thing here in this context, which is that the data that you're using for an article is findable, that others can access it, that it's interoperable and reusable, right? And those requirements are pretty strong by now in at least European funding agencies. And for these type of data, very challenging to accomplish, right? I mean, anything with the GPS location, there's so much statistical development still needed. How could you capture geoposition information or, you know, relevant activity? I mean, could we just, you know, create a feature and say, this is the radius in which people walked? I mean, not where it is on a map, but this is the size of it. And then in the data we pass on, we just measure the size or the distance to a hospital or the distance to a school, right? That could be the metric that we pass on. But the problem is if there's a lot of it, then eventually you can all put this back together on a map, right? And de-identify people and their locations, right? So this is very challenging. And so this balance of, you know, how much of this do we want and can we collect and can we keep safe is a pretty difficult one. I haven't seen yet in a good sort of data archive environment that allow for these unstructured data to have a home, right? I mean, there's the structured data, you know, think ICPSR, right? That's a data enclave where you know, data that have a regular structure, well kept and archived and stored. On the unstructured data side, much harder. So if you are aware of initiatives that do that, you know, let me know. Would love to learn how to pass these information on. And it's mountain of them. I mean, we had the study run for 6 months and, you know, all the people, all the pieces of information, we got way too much. What I also think is necessary here that we have, you know, a good way of then describing what we did to get information out of it, right? How did we, like all this feature engineering that happens ahead of time, how did we create that and archive that and make that as part of the information you pass on? Because there's so many decisions, like how do we treat missing data, information that doesn't come, the information that doesn't, you know, get transmitted in time, for example, right? And there are gaps. Is that because someone turned off their phone? Is that because you know, there is no measurement or what have you? So there's a lot of challenges around that piece. So with these, you know, difficult data, you know, there comes a challenge for being aware of, you know, errors that we have. And looking at the time, I think I need about 4 more minutes. That will cut down on the discussion time, but I'm gonna rush through this, not too hard, and then we'll, I think, have an hour afterwards to talk still. So let's leave the IIB Smart Study for a moment and just talk about sort of error and other found data types just for a moment so that you see what I mean with algorithmic dependence on these. For several summers, I had fun to type into Google image search the term university professor, and this is what I got back, okay? nice diverse on age and race, ethnicity, and whatnot, but not the kind of diversity that I was hoping to see. And then I gave a talk in 2019, and while I was talking, someone did this exact same search and held up their phone and said, "Not true, look at this." And indeed, it turns out that within, you know, a short period of time, Google had changed its algorithm, and I later on spoke to a woman who led that fairness team, and she said, yeah, that's exactly when we turned it on, you know. So they had changed the algorithms with which images get pushed back to the search, the person searching on all kinds of types of images. And what's nice here, it's a, you know, almost equal representation, maybe even more females than males, and certainly also not reflecting reality, you know. And that's sort of, for me, the key message, right? That with any of these data, that where you don't design the data collection, you just cannot assume that this reflects anything coming back to the descriptive statistic, right? There's no point estimates here that we can get from it. But the problem is, it's easy to spot that on the image search, because we sort of know how universities looks like. It's much harder to spot that on the kind of measurements that I was talking about before, right? There can be issues with the hardware, there can be issues with the user, there can be issues with the software. And, you know, won't have the time to go into details on all of these, but I can assure you, we spend months to go through each of these and learn what the issues are. So for example, here, women tend to not have the phone on them all the time. And, oops, now my calendar is telling me that this is over. Do you still see my slides, or did I mess them up?
We still see your slides.
Good.
Okay. Only I can't see them. Okay. Where are we?
Yeah, now it's showing the opening slide.
Okay, sorry. Then somehow. Okay, well, this is a good way to get interrupted here. So anyway, what I was gonna say is that females don't tend to wear their phone with them all the time, right? And so we have less activity measures overall for females, but as we noticed in looking closer, it's because, you know, they might have a handbag and they put that down, whereas males have it in their pocket in the pants. I mean, that's an hypothesis. We didn't actually ask people where they want the phone. We noticed that, you know, there's a lot of multiple device uses, and, you know, people that use apps that we wouldn't expect. And, you know, of course, shared devices. We could have thought about this earlier, right? Mothers or fathers that need to put the kid to quiet and give them their phone to do stuff on it, right? So there's like all kinds of things that distort the measurement that you going in probably wouldn't think about. The one funny one, and then I will close this out, we saw was GPS position. That too can be very misleading. You know, we noticed a couple of people who in record time went from Europe to Africa. You know, it turns out what they had installed was a GPS scrambler. There are apps that sort of scramble, you know, they just take the prior geo position where you were and then move, you know, latitude and longitude around and things like that, right? Easy things, once you know about them, you can spot them. But the main message here is they are, unlike the gender example with the Google search, so many ways that you might not immediately recognize that there's an error unless you really look closely, or you have sort of strong hypothesis. I mean, this one here is easy to spot because we know we can't fly there that far, right? But in other instances, you might not. And so, you know, more than ever, I think it is necessary to team up with people who have substantive knowledge to do that right. So on Jennifer's request, a last minute on the privacy and ethics of this. So there is a challenge in these. We spent a ton of time, in fact, 1.5 years in developing the material and convincing the stakeholders that it's okay to collect these data, and to make it really clear what we do with the data, to have this GDPR compliant, the European data protection regulations. But the biggest issue is sort of from an ethical point of view, that we are repurposing data that someone else shares with a company or whatever have you for a different reason. And think about this. Helen Nissenbaum, who is also, used to be at NYU, is now at Cornell Tech, you know, she gave me an example that so stuck with me. She said, if you show your ID to a bouncer at a bar, right? They look at your age, and that's the appropriate flow of information. That's the context that they're in. If they also look at your address and they show up at your house at night, that would be so inappropriate, right? And it's totally true. I mean, it's not that we didn't give this information, it's just understood there's a norm that you don't do that. And that's the same thing with the data, right? There was a norm that you put your data on Facebook, and it's shocking that it leaked, you know, but that Facebook had the data, no one had an issue with. We all knew that. We put our stuff up there, right? It was the repurposing in an unanticipated way that got people upset, right? All right, not going to show you my research on the data sharing. There's lots to say about that. But just to summarize, I do think that the social scientists need to be aware and, you know, take advantage of all these data that are rising. If we don't do it, others will, and they might not have the sufficient background and context knowledge and then just, you know, interpret the hell out of it. If we do that, we need to have very clear inferential goals, you know, to Jennifer's point, right? We need to know the limits, we need to know what we can do, and we probably need to combine the data with other sources to get that right, right? But then it's also important that we keep this part about what's ethical. I mean, we can do a lot more, I think, than we currently want to do from an ethical point of view, right? So having that in mind is very important. I wouldn't necessarily label it under privacy, because I think this is so context dependent, you know, that it really comes down to sort of what is appropriate, and Helen Nissenbaum contextual integrity framework is a good one for anyone who wants to engage into that kind of data collection and need guidance. So I'll leave it at that, and thank you. So saved a little bit of time for questions, not as much as I had hoped, but